You know, Jack and I both work for Microsoft. Our speaker works for Microsoft as well. So this is our own views. If we say anything that's, oh yeah, then, you know, this could be better or whatnot, it's our own views, not the view of Microsoft. No warranty support. I'll let you do this one because it's long.
As always, we have our diversity charter. So if at any point you don't feel welcome, this is all about being inclusive. So if at any time you feel threatened by that or you don't feel comfortable, please come and speak to one of the Silicon Brighton team or myself and Ryan. Ping us after the event. This event is for you guys, and we want to make sure that you feel welcome at these. So please do let us know if that isn't the case. Tonight's agenda, we're going to do a bit of an intro, which we're doing right now. We've then got Daniel doing an amazing talk on Azure Storage, something that we all use daily, but probably don't understand every bell and whistle of it. So looking forward to catching up on this tonight. We're going to wrap up, grab some more pizza. There'll be a break probably about halfway through your talk, Dan, just as a refreshment break. And then we can carry on with some networking and see where the evening leads us. Natasha, would you like to come and do a little bit of Runway East, our fabulous hosts in this fabulous venue this evening?
Good evening, and you're very, very welcome. So it's Natasha, and just on behalf of Runway East, we'd like to welcome you. If you haven't heard of Runway East, we're on a mission to destroy boring offices in London, Bristol, and now Brighton. We're quite new, but we do have space. So we host SMEs, startups, and entrepreneurs for up to 100 people. So if you're looking for a sociable yet dedicated desk for yourself, or a private, customized and swanky office, we do offer these. And recently we became a B Corp, so we get to host lots of lovely events like this where we get to connect with our community. So if you're looking for a new office home, do Google Runway East. Thank you.
Thank you very much.
Or Bing Runway East. Yeah. Actually, I'll probably pass over to Grace to just do a quick intro on Silicon Brighton. If you're new to the group tonight, we're supported by an awesome organisation called Silicon Brighton that run a load of other groups as well. So I'll let Grace just explain who they are.
Come over, thank you. Yes, I'm Grace and I run Silicon Brighton, and we consider ourselves to be the hosts of Brighton and Hove Tech Sector. So this is one of many, many meetups actually that happen across Brighton and Hove and the surrounding areas. There are about 30 groups altogether. All across sort of digital and technology skill sets and sectors. They're all free to attend, and they're all free and available to people at all different levels. I'm really sorry about my dog suddenly whining in the background. So I don't know what that communication method is. And they're all hybrid as well. So the idea is that we're trying to remove any sort of barriers to entry for people getting involved in these, attending, and yeah, using them as an opportunity really just to meet new people, learn new things. So tell your friends about them, check out the other groups, come to some others, get involved, maybe think about speaking or attending some others as well. These are all our amazing supporters. So these are businesses who contribute to us financially on a monthly basis to allow us to continue to keep these for free. And these are our values. So in the same way that Jack and Ryan have a diversity charter, we have a set of values here that really strongly resonate with us, but also all the people that come to our events, speak at our events, the partners that we work with as well. You can follow us on socials. We're on Twitter, Instagram, LinkedIn, and TikTok. So there's a really strong online as well as offline community. And just to give you a bit of an idea, I guess, about the breadth of different events that we host, there's a couple coming up over the next week, but we do have a full calendar of events on our website, so check that out. And again, continue the conversation online or away from in person. We've got a Slack group with, I think, Sussex is your channel on there as well. So great place to connect outside of today. Back to you.
Yes, so we have our next meetup on the 26th of March. You can scan the QR code to get your meetup already signed up for that. We've got a few current ideas. Those of you who know John in the room, we are discussing with John another fantastic talk on Entra SSE, some date to be confirmed. We've also got some AI stuff that is a hot topic, obviously, always at the moment, with a couple of speakers from Microsoft who are very keen to do all the way from the very top to all the way to the very depths of AI. So yeah, one not to be missed, but we'll let people know more about that in the coming weeks when we've worked that out and finalized some speakers. Also, with 2024 in mind, we are the last Tuesday of every month, every other month. So organized. Apart from May, because we had to move May to accommodate another group because there's a conference going on. But yeah, please do keep these dates in your calendar. These will hopefully not change, but if they do, we will of course let you know.
Yeah, so we've been playing with WhatsApp communities, and we've got a few, people on there, and we've had a few kind of technical questions. Johnny, you've been doing some really good technical questions, which has been really cool. So yeah, please join the group, and it doesn't have to be like a technical chat. It could be like, hey, I want to do this talk about something, or I did something really cool in my job that was Azure related, and maybe you guys want to hear about it on just the WhatsApp community rather than in one of these events or whatever. But just any ideas, just keep the kind of chat going, and everything else obviously optional, but we would love to see more people on it. And also everything that all of our events go on to our YouTube channel, and also the Silicon Brighton YouTube channel as well. So if you want some historic and legacy content, check out some of that. Some of it's better out of date. We probably need to do a bit of a cleanup at some point. And that's kind of it really. So I'm going to hand over to Dan to do an intro, and yeah, enjoy the talk.
Is this on there?
Yes.
Cool. Is that working? Cool. So thank you both. So I'm Daniel. I work for Microsoft along with these two. So I am an Azure Technology Specialist in the public sector team. So what that means is that I work with our public sector customers, advising them on Azure infrastructure of various different kinds. My background prior to Microsoft was all about data centers, so like big storage, VMware, Cisco, all that sort of thing, Windows Server. That's where I come from. So a lot of that I kind of bring with me, and there are some things that I like talking about still, storage being one of them. So I kind of I wanted to talk a bit about Azure Storage, A, because I find it interesting, and B, because Jack tells me it's been a while since that last came up as a topic. And I sort of thought, I don't want to make it just like this is Blob, this is files, etc., because anyone could do an AZ900 and learn that sort of thing. So it's a bit of a kind of mishmash of things across storage of various different topics, which hopefully will be interesting. Hopefully there'll be some stuff that you haven't seen before. But if at any point anyone wants to stop me and ask questions, please do, or at the end. As Ryan said, I'm taking my Microsoft hat off at this point. So whilst I think Azure Storage is very good and I like using it, I can't 100% guarantee the accuracy of everything in here and stand by it warranty-wise. So I've done my best to get everything right. So yeah, this is me. Among other things, I'm a collector of badges. So I like having lots and lots of badges. It was a bit of a hobby for a while to go around and see if I could tick off every single Microsoft badge that I could get. And what I was very disappointed to find with AWS, right? If you get, I think it's 11 they've got with AWS, and if you do all of them, you get a gold jacket. It's like a bomber jacket made out of gold, not like solid gold, that'd be expensive, but it is incredibly shiny, and you can find pictures of it on Google. And then I thought with Microsoft, that'd be really cool, except they just like every month they create new certifications. And if you factor in like Dynamics, there's like 60 or 70 of them or something like that. So it gets a bit bonkers. So I've kind of stopped collecting at this point because I ran out of space on my slide. So these are some of the storage kind of topics we're going to talk about. There is a bit about what is a blob, what is a file, but we're not going to stay for too long on that topic. I'm going to talk a bit about Azure NetApp files. So has anyone here used NetApp on premises before? So you okay, there's some familiar with NetApp. So there's a bit about what Azure NetApp files is and what it isn't. And I think it's a really cool product, and I like using it a lot. But yeah, we'll cover a bit of that. It's a little bit about something called Elastic SAN, which you may or may not have heard of. It's still, I think, in preview. Possibly not. I think it's going GA quite soon, but yeah, that's another bit of storage we have. And then there's some other sort of mishmash of things to cover. So that was a selection. We've actually got even more storage services than this, because this is on the documentation, and it's supposed to help you find the right storage product. I don't believe this would help anybody. And there's some stuff like Azure Files isn't actually on that list. And I don't know why. Maybe they forgot it. Maybe they're like, well, if you want files, you stick them in files. Why do we even have to write that down? But we have this many services and more. So there's an enormous number of different use cases, an enormous number of different storage types. And I think coming from an on-prem world, really on-prem, we had two things. We had NAS and we had SAN. They were the two types of storage that we had. And so everything kind of had to be shoehorned into one or other of those. So I remember having challenges with file systems that were, there's a particular workload that I used to work with where I think at one point we had something like 7 billion files with a B in the same file system. And NetApps really didn't cope with that very well at all at the time, but it was all we had. Object storage on-prem didn't exist. It was a choice between the two. So you find a lot of software made kind of really suboptimal design decisions around storage based on the fact that they expected 99% of their customers really only had one type of storage. Suddenly you move into the cloud and then you've gone from one or two kinds of storage to however many that is, and then more if you really wanted to. There's loads and loads. What that means is that you can change the way that you manage your applications, and you can actually do some really useful stuff that you just couldn't do before. So first of all, we're going to talk about storage accounts. So they are the kind of fundamental building block of storage in Azure, but they're not the only kind. So if you were to go on any kind of Azure course like an AZ 104, they kind of pretend that this is the only type of storage that exists. They'll say, right, everything's either a file or a blob. But actually the range is much wider. But fundamentally, the first two we've got are these ones. So these are the two that everybody's familiar with. We've got blob and file. And really, in most cases, a blob is just another type of file. It's a place where you store files. You just don't have a sort of hierarchical file system to store them in. And so which one of these you choose for many workloads, it depends an awful lot on who's going to access it, what method they're going to use for accessing it. Is it a human that's interacting with your data, or is it done programmatically? Are they users that you can authenticate, or are they anonymous users on the internet, and so on? And then you have to think about the sort of file system limitations as well. So blobs can store petabytes of data without any trouble. File systems really creak at the seams when it starts coming to that. And then the other two that we've got in here are table and queue storage. So they are the ones that they exist there for a specific reason. So there was a challenge that a developer wanted to store data in a certain format, and these are the tools that we give those developers. So table format is really, think of it like an Excel spreadsheet. You've got columns and you've got rows. It's that simple. Or it's like a really cheap version of Cosmos DB, which is big, global scale tables and rows like Excel. And they're there for, there's plenty of times when you actually want to store data in a columnar format. So at the moment, on a file system, you'd be constrained to doing that on a CSV file or in a SQL database or something like that. We give you a native table storage feature so that you can do that very, very cheaply with minimal effort. And I'll show you what I've used that for a bit later. And then there's queue storage. So I once worked with an application where you had two apps, and the interface between the two, they would pass messages to each other. So you'd create a record on one and it would sort of update a record on the other. And the way it did it was one of them would write to a text file on a file share, and every 5 minutes, the other one would come along and look at that file share to see if any new text files had appeared. And it was very, very, very easy to break it. So it had very, very poor consistency. If you recreate the same file 5 times, it would put the same message in the database and then complain about corruption. So queue storage is really a very simple, like, there is a bit of information that I want another application to read, and then when the other application has read it, I want that bit of information to go away because it's got from point A to point B and something happens in the distance. So those are all there to solve specific problems. But the one thing that unites all of these, apart from the fact that they come in storage accounts, is that they're the ones that the data plane is accessible over the REST API. So they're the ones where you can use the API not only to provision the resources and manage them, but also to access the data, which means that in any bit of code that you write using C# or Python or PowerShell or whatever you like, you can actually retrieve data from these without having to use any other file systems or libraries or anything like that, which makes them sort of very developer friendly. So actually under the hood, they're all the same storage. So this bit down here, this is the physical devices sitting in an Azure data center. We've got tape, we've got spinning disk, and we've got SSDs and NVMe. Really, the difference between blob and file is sort of up here at this front end layer. In the middle, you've got these layers that actually abstract and obfuscate the underlying storage, but they are all fundamentally sitting on the same bit, which is why you can turn on ZRS for one thing, and it's the same as turning a ZRS for another one. So we've got these multiple layers where over the years, I think what's happened is somebody invented sort of one storage product and then created the sort of the APIs and the abstraction layers, and the other protocols just got dumped on top of it without really having to reinvent the engine that sits underneath it. But the thing is, Ryan said to me when we were planning this, could you do some stuff around what it really looks like in the data center? I thought, well, I can have a look, and I couldn't find very much. Partly because they don't talk about it very much. It's very secret, and partly because I don't actually need to know. I don't care. If you're really interested, so I'm sure many of you have seen Mark Prasinovich's videos on YouTube from his Ignite videos and stuff like that. He does plenty of talks on how these things work, including like Project Silica, which is one about burning into glass. There's another one I heard about, Project something, I forget what it's called, started with a P, but it was about using DNA to store data, and you could store 10 terabytes of DNA in a drop of 10 terabytes of data in a drop of DNA that big. I thought this is very bizarre. And yeah, I worry if you combine that with like OpenAI, does it actually form a new life form? But yeah, I don't have to think about these things very much. And this alarms people. So sometimes we say to our customers, actually under the hood, Azure Archive Storage is just tape. And they get very, very upset about that. And they say, well, we can't possibly use Azure Archive Storage because, tape is dangerous, tapes degrade. So that's out of the question for us. And what happens with these many, many abstraction layers is that the service we present to you with all the SLAs and the durability guarantees, it shouldn't matter what's underneath it. The fact that it's on tape shouldn't actually be a factor in your decision to use something, because we stand for the durability guarantees. We spread it across like 10 tapes and 10 data centers or whatever, but it's still ultimately magnetic tape. So I think understand which of these protocols you can use for your application, then exactly how that gets delivered to you kind of doesn't matter too much. So we've got a number of different protocols. So you probably, if you're from the on-prem world, you've kind of got the file protocols and you've got iSCSI. You might have Fiber Channel as well. And so you can see that the REST APIs, they're the native services. They're the ones over here that you can actually use to access the data. But we've got this other kind of mishmash. So the file protocols, they're the ones where you have a file system that natively understands what is a file. So you can do things like sparse file streaming. You can do things like apply permissions to individual files. It might support things like file level backup and restore and deduplication. But ultimately, your file system knows what is a file. The block ones have no such concept. They see a block of data that has a start and an end, and it's a certain size. And then you've got the sort of proprietary ones like SFTP and HTTPS. Now, the difference between the file and block ones, now the file ones are great for if what you're dealing with comes in a nice, neat, easy file format. So if it's, it could be VMDK files, it could be VHDs, it could be SQL database files, whatever it is, as long as it is a file and you want to use file-like semantics on it, it's perfect for that. The block ones, they're useful for something where you have to stick your own file system on top. So that might just be because it's a virtual machine and you want an NTFS file system, or it might be that you want to use something like, you've got high-performance compute file systems like Lustre, you've got Oracle ASM, where Oracle Database wants to manage its own storage for you because it thinks it will do a better job. They're the ones where you can provision block storage, and they take away some of that functionality like file level restore, but they do give you an awful lot of sort of performance and other benefits. And then we've got the ones over here. So we've talked about the REST APIs. They're there for developers to be able to use file systems without really having to deal with protocols themselves. And we've got a couple of funny little stragglers here. We've got SFTP and HTTPS. So HTTPS is really about you can serve files over the internet, over HTTPS, out of blob storage, very, very cheaply and easily. And SFTP is a feature that I think another large cloud provider had first, and eventually arrived on Azure as well. But what that does is if you've ever had to deal with third-party organizations where they upload data to you via SFTP, which is bizarrely common, it's like fax machines, it just will not go away. That's what SFTP is for. And previously, you would have had to build a virtual machine. You have to manage the security, the patching, the storage on it, and so on. Now, on a storage account, you can just flick a switch. It becomes an SFTP server. And what you upload through the front end via an SFTP client, you can then download at the back end through Blob storage. So it's a way for presenting that protocol and that interface. I'm sorry, am I messing with the camera? We're walking with. So this is the only table I've got with loads of numbers, partly because it took me ages to put together, and partly because it's almost entirely inaccurate. Because these numbers are really hard to get, and by the time, like I wrote this 2 weeks ago, and by the time I talk, something would have changed on here. And this isn't really intended for you to be able to memorize and go into an exam and say how many IOPS you get out of X, Y, Z. It's really just to put some kind of perspective around which ones are more performance focused and which ones are less performance focused. So for example, when we talk about managed disk, I'll come on to performance there in a little bit, but what IOPS is how many read and write operations per second the storage device can handle. And this depends on an awful lot of things. It depends on like how big are your blocks. There are some people over there, Jack. It depends on how big your blocks are. Like, are they random or are they sequential? Are they what is it over a network or block or file protocol? So there's an awful lot of variables there. But there are a couple of sort of outliers here. So if we look at Azure File Standard, that gives you about 1,000 IOPS, which is absolutely fine for your noddy little file share where you occasionally open a document. And then you've got this one here, which is NetApp files, which goes up to 450,000 IOPS. So that's 450 times the performance of one file system on another file system when they really should just be variants of the same thing. So I think this kind of shows you that there's a massive range, both in the protocols in sort of one direction and in the performance in the other direction. If you imagine a sort of quadrant, and you have to pick like, what am I trying to do with my data? And how quickly am I trying to do it with my data? And then you arrive at more or less the right point. So going back to that sort of weird tree thing at the start, the decision tree, that didn't even have anything about performance on it. So that's another data point you need to think about. So yeah, they're all measured in slightly different ways, but broadly speaking, there's this very large range of performance types. So one way to get nice, easy, quick, cheap performance boost, very cleverly named, is this thing here. So I only mention it because they did an awful lot of talking about it at Ignite, and it'd be rude of me not to mention it. But Azure Boost is something that has been built into the Azure platform in the last, well, it's been a couple of years, but it's been getting better and better. So what Azure Boost is a way that you can, well, you don't have to do anything at all. If you select certain virtual machine sizes, what happens is the hypervisor host has got one of those chips in the back of it. That's something called a DPU, or data processing unit. So it's a special kind of FPGA that I think VMware, they're becoming quite popular. So VMware supported them as of version 8. You can stick them in a VMware host. And what that does is it offloads a lot of the I/O, so the network and disk I/O, off the CPU in the host onto this dedicated chip. And what we get from that, remember on my graph before, the number of IOPS we were getting from storage ranged from 1,000 to the cheapest storage and up to 500,000 on the really super duper fancy NetApp storage. This will give us up to 4 million IOPS on a local SSD. So that's 4,000 times more than an Azure Storage account. And it gives us some absolutely bonkers performance numbers. without really having to do any work at all. So you can see in the portal like which VM SKUs are Azure Boost enabled. But if you've got sort of challenging workloads that have sort of performance considerations, you can give yourselves a really cheap upgrade just by picking one of these virtual machines. And the sort of the factor of improvement is really quite impressive. But there's a few other things we need to talk about with performance. One of them is latency. So latency is when you try to write to a bit of storage, you initiate your write over here, somewhere in your compute, and over here is your storage, and either you want to do a write, so you want to write some data and get an acknowledgement back that it has been successfully written, or you want to read some data, so you send a request, and back the other way comes your bit of data. And one of the big differences between, just to give you a third dimension, because we've had access and we've had IOPS and throughput. The third dimension, in a sense, is latency. And latency is what differentiates some things like Azure File Standard versus Premium. So in theory, both of them sort of work the same way, but one of them is much lower latency than the other. And when you consider latency of storage, there's a couple of things to think about. One is the natural latency of the storage account itself, which is over here. So this is, if you imagine like Azure Files Standard would be kind of there, and Azure Files Premium would be there. And then there's where do you put the client? How far away is the client? So how much latency is being generated outside of the storage? And I do see customers who might do something like build a file share for general purpose, documents and so on, and decide that they need Azure Files Premium because of the high performance, and then stick it at the other end of a point-to-point VPN to somebody's broadband at home, which is like, what, 30 milliseconds of latency to get from their house in Wolverhampton into the Azure data center. And it's very easy to undermine the performance benefits of one part of the stack by ignoring the rest of them, as we'll see shortly. So it's what you really need to do is measure the end-to-end latency that you're trying to achieve and consider, well, what are the building blocks that make this up? And you can optimize one building block by spending loads of money and ignore the rest of them, when actually something like SMB over quick rather than a VPN might be a much cheaper way of doing things, or a much better way of doing things, because suddenly you take a VPN out of the equation, you don't have to worry about routes and so on. So for every decision you make, it's very easy to say, right, I'm going to get the best possible performance, so I'm going to choose the best possible storage, and then ignore everything else that sits with it. So you need to think about, it is really difficult to try and performance optimize every single component in a complex application, but sometimes it is necessary. Or you just say, well, this bit here, it doesn't matter if I pick the cheapest service, because the cheapest service is still good enough, because really the problem is over here. So I'm going to move again. It's just that the stuff I'm trying to point at is on the other side of the screen. Maybe I should stand here and point. So what's going on inside a virtual machine? I told you it'd be a bit of a whistle-stop tour. So within a virtual machine, we'll start with managed disks, because they're a very simple kind of storage. And if you're used to hypervisors on-prem, you've got VMware, Hyper-V, Citrix, Zen Server, or whatever it's called these days. And they all do this. They all have managed disks. So if you attach a VMDK to a VMware virtual machine, that's just a managed disk. Same with VHD and Hyper-V. And we've got a couple of different kinds of storage here. So firstly, we've got the blob. So this is a special kind of blob called a page blob. And the reason it's a page blob is because a storage VHD is divided up into large pages. I think it's, what, 2 megabytes a page or something like that, but it varies between protocols. So a page blob is a special kind of blob where you can request sort of certain sections of it with a start address and an end address, and you just get that block of data delivered to you. And let's pick the simplest possible path. So we've got an uncached disk. So this is the virtual machine, has a disk, it has a E drive attached to it. That disk just gets sent straight down the network to the Azure Blob service, and it gets a block of data back, which is, very simple, nice and easy. We've also got something called a cache managed disk. And you see there's this server SSD over here. Now, every Azure host has inside it a certain amount of NVMe memory. And what you can do with that is a couple of things. Firstly, you can turn on caching. So on your managed disk, you can say, I want to store the most frequently accessed blocks of this storage down here on that server SSD. So what happens is if it's a cached disk, you flick a switch for this in the portal. If it's a cached disk, it will go down here, look for your block of data. If it gets it, returns nice and quick back to there. And remember, that can have up to 4 million IOPS on a single device. If it misses, if it does a cache miss, so the block of data isn't there, then it just goes straight back down the same path as everything else. So that makes a cache hit very efficient because you're potentially getting, 5 to 10 times the performance here. There's on managed disks. So if it's a cache miss, it becomes more expensive because you've wasted an IO by going here, and then you come back here and you go all the way down that stack, down the other side. So you're actually generating more work for yourself. You'll see in a second. Yeah. So, well, that's my next slide, I think. And the other thing you can do with a server SSD is you can create temporary disks on your virtual machine. So you'll often see if you create a virtual machine with, I think is it the D in the name? They've all got like the D4DS, the little D. I think the little D is the one that says it comes with a local disk, I think. If you ever want to see what all those codes stand for, do you know AzurePrice.net is a really useful website? Go to AzurePrice.net and it lists all of the Azure Virtual Machine SKUs and you can compare them all. And if you mouse over one of them, it tells you what all the little letters in the name stand for, which is really useful to remember because I never can. But what you'll get is a disk that's stored locally on there, and AWS calls them something. AWS has got something equivalent. Which I can't remember the name of, but yeah, AWS virtual machines have the same thing. And that is a virtual machine disk that is stored locally on the SSD. Now, the upside of that is you get incredibly good performance. The downside of it is if your virtual machine moves to another host, all that data's gone. So don't put the crown jewels on there, but it can be really useful. So if you've got those types of virtual machines that use transactional data, so they're high performance compute, maybe using spot VMs or something like that because they're cheap. If you retrieve a bunch of data from a centralized source, do a load of local processing, and then upload the results, this is a really good way of getting incredibly fast performance, as long as you know what you're doing with them. Stuff like TempDB on a SQL database, TempDB gets wiped every time you restart the database anyway, so it doesn't matter if it's on sort of ephemeral storage. So you can use them, just don't accidentally put important things on a temp disk because that's a terrible idea. So yes, caching. In the portal, we've got this option to cache data, and we can either have things with no caching, we can have read-write caching or read-only caching. And if caching is better for performance, you would think, well, why don't we just always turn that on? Because we like performance. And it comes down to the type of caching. So let's see what happens. First of all, what happens when we get a successful cache hit? When we want to do a read, so our virtual machine goes to the cache, says, I would like this block of data, please. Cache says, yep, got that. Back you go. Great performance, nice and easy. If we get a cache miss, we've suddenly doubled the number of IO operations because it goes there for a read. That says, no, haven't got it. Go to there, retrieve the file, pass it back. On the way back, it gets cached here. So you are sending your request to the cache. Cache says, no, I haven't got it. That gets passed down the stack to the data disk. So we've got a write operation onto the cache and then another write operation into the VM. And the idea there is that, well, the next time you go and get that block, it will be fast. But this time it's a little bit slower just as a penalty because we had to go all the way to the back of the building and go through the shelf and find the right thing. So a read is a little bit more expensive if it's a miss than it would be if there was no caching whatsoever. But the upside is that a read hit is nice and quick. Now on a write, on a read-only cache, this is called this is something called a write-through cache. So what happens here is that, again, we've got the same thing. It writes it once to there and once to there. So every time you do a write, the virtual machine is expecting that the block that you just wrote is going to get read back again quite soon. So it writes it to the cache. So it goes, when you next ask for this block in about 5 minutes, I've got it. And then it does a second write over to here. What that means is that it's called read-only caching. So you think, well, why is it writing to cache? What that means is it's not using the cache to accelerate the write. It's using the cache to accelerate a future read, but not the current write, because actually the write is very expensive. If that cache didn't exist, it would just go straight from there to there, write it over there. But because we're trying to predict future read performance, we're writing it here. That means that actually, in some cases, this is a suboptimal way of writing data. And then the most dangerous one is this one here. So this is write caching, where we're trying to accelerate write performance. So we're writing directly to cache. And remember, we get millions of IOPS here. So this is very, very fast write operation. But then what happens is something called a lazy write. And that means that every now and again, rather than committing to both locations straight away, it means that every now and again it's going to flush everything out to the disk. And every now and again just means that the writes are super fast, because it's really just chucking all these bits of paper out the window and hoping that at the bottom somebody is gathering them all up and then saving them somewhere sensible. If you lose device power during this and you haven't committed all your lazy writes, that data is gone. So if you've got an on-prem NetApp, they protect against things like that. They also do this thing called write-back caching. A NetApp will protect itself against this because it uses non-volatile memory to actually do the writes onto. So even if you lose power, this maintains its data. In the Azure host, that doesn't happen. So in answer to the question about what should you and what should you not cache, it's down to kind of what does the application expect to happen when data goes to a disk. So the types of things that we think caching is a good idea: operating system disks, web servers, file servers. So file servers, where people write files and they regularly reopen the same file that recently got written. And if it's a file server that's full of like Office documents, it often doesn't matter very much if you lose 60 seconds worth of data on there or something like that. That's not a business critical type of problem. High performance compute and databases and so on. So databases, we're talking about the data files of a SQL Oracle database. So they're the ones where we just want to write, and they will probably read back, but they are lots of very random reads and writes. They're not sequential, they're random. Now, the ones where we think this is a terrible idea, transaction logs. And you mentioned Active Directory Domain Controller. So sysvol is fundamentally a transactional database. So what happens in there is you've got all these transactions that are being written. And the idea of a transaction log in an ACID compliant database is that it's there for durability of the data. That's literally the point in a transaction log. So if you're writing a durable bit of data onto non-durable storage, it rather undermines the point of it. If you're writing, bear in mind with a transaction log, you almost never read the transaction log back again. It's just there for that durability. So this is a bit pointless. You're incurring 2 write operations when you could get away with 1. So actually on a transaction log, just have no caching whatsoever, just go straight to disk. Backups, again, you want raw throughput when it comes to backup data. You're not going to read the data again in most cases. And they're there for business criticality. So again, you don't want the risk of data loss during a backup. Email servers are just big transactional databases. So those are the type of workloads where actually this would be pointless because you're writing more than you need to. And this would be pointless because you're just chucking your files out a window and the guy who's supposed to catch the bits of paper might not be standing there right now. So that's the different types of caching that we've got within the database. So the question is, well, how do we get around this? So we have limits on the performance that you can get out of a single disk in Azure. And if you look at a single disk, a single VM, it's got these maximums. So it's different for every single virtual machine, but this is a D8S V3. It's got a cached and temp storage. So that means like how quickly is it allowed to read from the built-in SSD of 16,000 IOPS and an uncached of 12,800 IOPS. And what that's kind of a software cap. Once it gets to that limit, it will be throttled by the host. And that's different for each one. So if I wanted, say, 25,000 IOPS from my application because I need it, because it's a big, busy SQL database, what can I do? I can go to the next size virtual machine because that's got a higher limit. But if it's a SQL database, I've just doubled my licensing cost by doing that, and I might not need to do that. So the other option is we mix and match. So if you think about, we've got 16,000 IOPS of cached and 12,000 IOPS of uncached. Well, we can have 2 uncached disks and 3 cached disks, and together, each of those stays below the limit. So we get maximum throughput without any throttling from all of those. We get our 25,000 IOPS without actually having to change the VM size. But again, I was looking at these, and D8 SV3 was that much, and a D8 SV2 or something like that was about a third as much IOPS. So that suggests that this is probably a Boost VM of some kind. There's probably a Boost chip in this server. But for each family of virtual machines, there's a massive page that lists like every single bit of Intel chipset magic inside the host. And I never read any of it because I can't finish a single sentence. But there's another trick. So say we've got to our 25,000 IOPS, and we're still hammering our database. We just want more and more and more faster storage. What else can we do? Well, the thing is, we've also got this number over here, which is network bandwidth. How much bandwidth can we get out of the network adapter? Now, these are going straight to the host and using the host storage I/O throughput. This completely bypasses that because it's a totally different I/O number and an I/O cap. So these ones here, we've maxed out our managed disks. We need more storage, so we can use something like Elastic SAN. Now, Elastic SAN, also a block protocol. If you're using on-prem storage, you know what iSCSI is. It presents blocks it presents block-based storage to the virtual machines using iSCSI. What that means, it's the SCSI protocol stack, so it's it's intended for enterprise storage, but it's just doing it over a network. This is one thing that sort of took me a bit of head scratching. I thought, well, the on-prem world, this is really difficult to do because iSCSI is one of those things that sounds simple, but it takes an awful lot of design to get it right. Because you can, if you've ever done like a Microsoft course, you've probably set up iSCSI. It's like type in an IQ in here and add some permissions here and storage. But then actually getting it right at a sort of enterprise scale is really difficult because of performance. So things like if you buy the wrong 10 gigabit Cisco switch that's got the wrong size port buffers on it, your iSCSI just goes absolutely down the pan because you've got like not enough port buffers to actually be able to store block pages of data because it was intended for different types of data workloads. And I thought, well, how can an Azure network possibly be optimized for this type of storage and all other types of data at the same time? And I thought, I just don't need to care about that stuff because the Azure engine magic does it for me. If Microsoft have built a networking stack and told me that I can get 80,000 IOPS out of an Elastic SAN, I'm just going to trust that that's happened. I can test it, but I'm just not going to worry about, is this the right kind of cable and the right kind of QSFTP that everything's plugged into and all that sort of thing. So if you need additional high performance storage on your virtual machines, Elastic SAN is one way of doing it. Now, Elastic SAN has a few other advantages. So one is that managed disk block storage is really difficult to manage at scale. So if you've got lots of virtual machines, lots of virtual disks, managed disks that you're trying to attach to different VMs, it becomes really, really difficult to do because you like, how do you manage the access rules? How do you connect one disk to another virtual machine dynamically on virtual machine provisioning time and so on? Elastic SAN kind of takes that problem away because if you're used to managing SANs, you've got this concept of volume groups. And whatever they're called in different SANs, they're largely the same thing. And a volume group is where you've got a set of different volumes that all have the same networking configuration. So all of those hosts over there, all of those initiators, in SCSI terminology, can access all of these storage targets over here. And you just set one rule for the whole thing. And it makes it really easy for, if you've got things that are being dynamically created and destroyed all the time, things like containers, to attach persistent storage to them programmatically becomes so much easier with something like Elastic-SAN than with managed disks. And in fact, there is another new service called container storage. And what container storage does is it automates the provisioning of persistent storage for containers and the mapping. And it has 3 different underlying tools. It can automate Elastic-SAN, Azure Files, and temporary SSD. So any one of those 3, if you're using AKS, you can actually get container storage to do the orchestration and the mapping of volume to container, volume to container. It comes with all of the other stuff that you would expect, things like snapshot, ZRS, encryption, all that sort of thing, private endpoints, which is what you know and love from the other storage types. But it can be quite a good fit for virtual machines where having a managed disk just isn't the right thing to do. Yes.
Capability. I've got a few customers where they were having to scale out ESX nodes in Azure VMware Solution to add storage, but now with this, they can just add Elastic-SAN and save a huge amount of money on AVS.
Only trouble with that is I wouldn't do that with a preview feature.
Of course, yeah.
But yes, other than that, again, coming back to those, if you've got those type of applications that want to manage their own block file systems, and particularly things like Microsoft Windows failover clustering. So if you've got a Windows failover cluster, you can do it with Elastic-SAN, but also if you've got Oracle ASM, you've got Lustre type file systems, you've got Linux LVMs and so on. Yes, yeah, I can go in there and create one now. But yeah, the thing with preview features is they usually work. You do get fairly minimal notice if they're going to change something, but what you don't get with them is the SLAs. So it's kind of at your own peril, do you use this in production? That's the one thing that's missing from preview features is any guarantee of uptime. And we talk about single-digit latency. What that means is that it's a latency number that's typically between 1 and 9 milliseconds, which is not like blazingly fast, but it's not bad. Sub-millisecond latency is what we'd expect from really high-performance file systems. If you're on-prem, you typically expect that something like an SSD is usually between sort of 0.5 and 1.5 milliseconds. A SAS disk maybe like 5 to 15 milliseconds, and a SATA disk is like 20 plus milliseconds. So that's the kind of order of comparison. And the other thing we've got for AVS is this jazzy little thing. Well, one of them. We've got Azure NetApp files. We've also got something called Cloud Volumes Ontap. And I'll just clarify what the difference is between the two. Now, this might not make sense for those of you who have never touched a NetApp in your life. So you can ignore this bit. But firstly, Azure NetApp files, it's a first-party Microsoft product. So what that means is Microsoft built it and sell it. Under the hood, in the Azure data centers, there is NetApp hardware. So NetApp do really good storage hardware. It runs an operating system called Ontap. And what's happened is that Microsoft have bought a load of ANF, a load of NetApp storage systems, wheeled them in on pallet trucks, stuck them in the corner of the Azure data center, plugged them in, and then put the Azure REST APIs over the top of Ontap. So when you provision stuff through the Azure portal and the Azure APIs, in the background, it is orchestrating the creation of NetApp volumes and aggregates and so on. It's a NAS, which means it supports NFS or SMB. It's very, very high performance. So we saw those numbers going up to sort of 10 gigabytes per second. That's gigabytes per second if it's storage, not gigabits. It's up to 500,000 IOPS. It is very good for things like AVS is a really great one. So if you imagine AVS well, where you've got lots of virtual machines that require high performance storage. SAP HANA, Microsoft SQL. It's common for AVD as well. So there was this limitation with Azure Virtual Desktop where it could, I think the root of a file system could only have something like 2,000 file handles on it. So if you've got more than 2,000 AVD users, you can basically break your entire file system because people can't open their profiles. ANF got around that problem. I think that's fixed in Azure Files now. I think the limit's increased, but that was a good use case for it. And other types of HPC applications. The other thing that's been around for quite a bit longer is Cloud Volumes Ontap. So where ANF is Azure front end, NetApp back end, Cloud Volumes Ontap is the complete opposite. So it's taking Azure virtual machines and Azure Blob storage and installing Ontap onto them. So if you like Ontap as an operating system, if you've got it on-prem, if you want to replicate your on-prem data into Azure and still have it in the NetApp ecosystem, that's what Cloud Volumes Ontap is for. You may be able to get some sort of storage efficiency out of it because it's got dedupe and compression and stuff like that. But really, it's intended for people who already use NetApp and want, say, for example, their DR systems to be in Azure. And I'd say out of the two, ANF, being a first-party Microsoft service, is really sort of one of the front runners of the most popular services that I talk about. Cloud Volumes Ontap is there for the customers who want it, shall we say. So I did find this jazzy little picture that shows me the difference between the two. I'm not sure how useful it really is, but the important bit is sort of this bit down here. With CVO, you manage Ontap. So you log into Ontap, you get the GUI. I'm going back. It's fine. You get the GUI. You get all the. You basically you can interact directly with Ontap. You can run commands against it. With Azure NetApp Files, you do not touch Ontap. The fact that Ontap is there doesn't affect you. You are not allowed to interact with it. You just interact with the Azure portal. So I'll just for a moment, I'm going to actually sit down for a bit. Oh yeah, actually, yeah. Oh, goodness. Okay. Go ahead. Oh, I forgot
Really
we're
good.
streaming to the world.
Yeah, we are
I'm
streaming
a
to the
famous
world. So,
YouTuber.
you're live on Channel 4. Please do not swear. There's been a question online about, is ANF faster than vSAN in AVS?
No.
And that's purely because of the network latency, right?
Well, yeah, but basically vSAN and AVS uses NVMe disks that are physically inside the server. So you've got shorter latency because it's, you've got about 3 inches of cable you've got to go through. And it's NVMe with no abstraction from one end to the other. So yes, vSAN. Also, vSAN is replicated because you've got the erasure coding across the nodes. So vSAN, you would be able to read from a local copy of the data on every single node in a sort of fairly simple configuration. So yeah, vSAN will always be better performance. That said, who needs that much performance for their virtual machines? A lot of your virtual machine is really just a Windows operating system disk, and most of the I/O it needs to interact with is actually coming across the network. So it's a good selling point for vSAN, but it's like there is a point at which you just don't need more performance. But where that's useful is, as Ryan said earlier, so an AVS node has between about 15 and 20 terabytes of NVMe storage in it. The minimum is a 3-node cluster. So if you imagine you had 3 nodes with 20 terabytes each, that's what, 58-ish terabytes of data you can store. So you are scaling CPU, memory, and disk storage all at the same time. If you've got big SQL databases, you might not need all of the CPU and all of the memory, but you've filled up your disk storage. So your options are two. Either you can buy another AVS node, which you would then need to use. You'd then need to buy the CPU and memory for it, even if you're not actually using it. Or you can augment it with scaling storage separately using ANF. So what happens there is you provision some Azure NetApp Files storage in your data center. You provision it to the AVS cluster as a NFS file share, and you use that for your virtual machine disk. Same as you can on-prem. You can attach NFS to VMware vSphere. And the one thing that you need to think about here is this funny little express route here. And we all know express route for getting back to your on-premises data centers. But actually, AVS is this funny little service that exists outside Azure Resource Manager. So AVS, technically, it's kind of like its own tiny little data center in Azure. It sits outside of the virtual network kind of structure. So because it's installed directly on tin. So to connect the AVS nodes at one end of the Azure data center to the virtual network where all of your other stuff is, you actually need an internal express route, because express route is the method you get from not Azure VNet to Azure VNet. And what we often recommend, so this one here always gets provisioned when you're using AVS. So I don't have to move about all the time. I should point out I'm colorblind. I can't actually see it.
Really?
Yeah.
You can try, can't you?
Anyway, express route gets deployed, but you also deploy a second express route for the Azure NetApp files, and you set up global reach. So you've got the AVS and the ANF communicating with each other through express route global reach, the same way as you would do if they were two different buildings in two different regions communicating. So what you get then is this express route will go up to, what is it, 10 gigabit through an express route ultra SKU. So that's where you get your very high performance. So just to show you a bit what that performance looks like. Let me show you. So I have some Azure NetApp file storage, and what we have is this really handy calculator that's on a website somewhere, and this will tell you how much performance you can expect out of an ANF system. So you've got these three different kinds: standard, premium, and ultra, and each of them gives you a certain amount of megabits. Megabytes, that is megabytes, and performance per terabyte of storage. So in this one, you get 16 megabytes per second of throughput per terabyte of storage. So if I type in, for example, 20 terabytes, I can expect, let's see, I'm going to do 4K random, so I'm not going to do sequential data. I'll do 4K random IOs, 50% read. I should expect about 82,000 IOPS out of that. You'll see that these numbers here, the premium and ultra, they are the same for IOPS and megabytes, but they are, depending on your configuration, the ultra can go higher. So there are some caps, but if we set that to, say, the maximum, which is 100, that's where we get to our sort of almost 450,000 IOPS here. And there's a lot of tinkering you can do with like the different types of throughput, but effectively you get your sort of calculation about how much storage to expect from each one. This one would cost me about $3,000 a month. So just for comparison, I find that the price difference between Azure NetApp Files Standard and Azure Files Premium is negligible. There's usually very little difference between ANF Standard and Azure Files Premium. So all other things being equal, I would often choose ANF because it's so simple to configure. But you might have other requirements for one over the other, things like data protection and security and so on. So what I'm going to do is I'm going to show you what this looks like. I've created an ANF volume. Azure NetApp Files does not include the express route, but you only really need the express route if you're using it with AVS, because AVS also sits on an express route. AVS includes a free express route. Azure NetApp Files normally is VNet integrated. It's only if you really need that really high throughput to something else that you kind of need express route there. Oh, I've just noticed that this power socket is not live. And there are no electrons going into my computer. So, right. Yes, I think we'll do that. We'll take a charging break. we'll look at that in a minute. Anyway, I got my volume, so I created a 20 terabyte capacity pool, which is this one here. Within my 20 terabyte capacity pool, so the storage quota applies to a capacity pool. Within there, I've created a volume. I've got this one here, which is NFS. And I'm going to mount it up. So it just tells me, like, run these commands on your Linux virtual machine to mount it. So I'm going to do that. Am I going to do that? Okay. And then I'm going to run a performance test against it. So let's do a read performance test. So FIO is just a command line sort of performance testing utility. I did see if there was some way I can make this bigger, but unfortunately, Azure Bastion doesn't seem to have very good support for changing fonts and stuff like that. So running our little performance test, you remember we were promised 82,000 IOPS. And I'm running this, and what was it, 320 megabytes per second. And this isn't quite giving me that. So I'm running this performance test for a minute, and this isn't giving me the performance I was promised. So I'm thinking, have I been sold a duff one here? Because all these storage providers, they'll claim, oh yeah, 1 billion IOPS, you know, best performance in the world. And you actually deploy them. And it's like, oh yeah, it's like petrol mileage on a car. It's like that happened once in a lab, and you tweaked all the different knobs on the spreadsheet to make it look like that, and it will never happen again. So I did this testing. I thought, well, okay, fine. You know, we all accept that storage doesn't work like that. And I started doing some digging. Well, there's only really 3 things it could be. One is the network. So is there something occurring on the network that's slowing down my collection? It's like, no, I'm not connected to an ANF volume that's in Western Australia. It's on the same side of the planet as me, so I haven't got light speed to worry about. I trust that the Azure Virtual Network performs the way it should. I have checked that the virtual machine size is big enough, so it's got enough network throughput to be able to handle that. So why am I only getting, was it 60K IOPS and 250 meg when I should be getting more? Well, the third thing to think about, oh, thank you. Oh, no. What? Oh, there we go. Oh, I'll have electrons. Phew. Thank you. Oh, we don't need to take a break now. No, we'll still take a break. But the other thing is, this is NFS. And if you've ever dealt with NFS, you know it's really fussy about mount options. And people like NetApp, they issue some really good guidance around these things. So if you're ever using something like Oracle database on a NetApp, they will issue a document that says, we've tested like 400 different combinations of mount options for NFS, and these are the ones we recommend you use. And typically, they can make a very large difference. So you'll notice on the earlier slide when we had protocols, we had NFS version 3 and version 4. The difference between those two, NFS 3 dates back to the mid-90s. NFS 4 is from about 2010. And it's not necessarily the case that NFS 4 is better. The two things it brings with it, one is Kerberos authentication and encryption, which NFS 3 doesn't really do security. And the other one is it's got some semantics around file locking and file leasing and stuff like that. But NFS has an awful lot of mount options that it's very fussy about. And there's this new one that Azure NetApp Files has supported for a while, and ANF has only, no, Azure Files has only just supported very recently, which is called the NConnect. So I'm going to do a mount, and I'm going to remount that. But this string of things here, this is am I using TCP or UDP? What's my window size? Is it read write or read only? I'm going to append NConnect equals 8. And what that does is it increases the number of concurrent processes that can access the storage. So if you're using something like a database, let's see if we can do this again, where you can, the equivalent in SQL would be max DOP. So if you can increase max DOP on your SQL database, it just increases that parallelization. And suddenly I'm getting my 320 megabytes, and my 82,000 IOPS. So really, I can't call up Microsoft and say, you sold me some duff storage that doesn't perform, because it was my fault for not reading the manual properly and putting the right options when I mounted it. So again, it comes back to sort of understanding all the factors that influence performance all the way throughout your entire stack, because there can be an awful lot more than you thought about. But what's happening here is that the ANF storage system, the big all-flash FAS sitting in the Azure data center, is laughing and saying, you thought it was my fault. I laugh at your 80,000 IOPS. In fact, I'm going to cap you at 80K IOPS, and then I'm just going to go and have a little snooze with the rest of my capacity, because it's really not me that's the problem here. So there we go. That is how you get the best possible throughput on Azure Storage. Now, the rest of the talk is less about performance. So shall we? I'm getting a little wavy finger. Oh, we are going to keep going. Should we? You sure? I don't. Does anyone else? How much? Okay. Anyway, back to here. So, random smorgasbord of other storage-related topics. SMB over quick. For a very long time, sharing Windows file servers over the internet was a very dirty word. It's not something you ever did. It was very, very dangerous because the SMB protocol had an awful lot of vulnerabilities in it. It was very easy to break into, and it was also terribly, terribly slow. So if you've got people sitting at home trying to access Windows file shares, this was very poorly performing. So something that's come out quite recently is SMB over this protocol called Quick, and Quick runs under UDP. I did look it up to see if it stands for something, but it doesn't. SMB over Quick runs over UDP, much lower latency. It runs over port 443 and encapsulates every single session in a TLS 1.3 tunnel that is basically authenticated both ways with certificates. So you can use Kerberos even without line of sight to domain controller, because you can install a KDC proxy on the SMB Quick server. And it's supported on some fairly new versions of Windows, including Windows Server v.next, which now has a name. It's Windows Server 2025, which is coming out soon. But that is just a useful feature, which until recently you can only do on Windows Server 2022. But again, it's this whole thing that John was talking about last time, which is around really getting rid of things like legacy VPNs, because you don't have to have a VPN for absolutely everything nowadays. Fun feature. Anyway, I've got a few things to cover on blob storage. How am I doing for time? I'm okay. Yeah. So a bit about blob storage, and then that's what I have to talk about. So firstly, I just wanted to point out this little graph. So the thing with blob storage is it's really awkward to price, because you have to pay for the data at rest, and then you pay depending on how much you access the data. And it makes it really awkward to figure out what something is going to cost before you put it in Azure. And there's this spreadsheet, and I obviously understand that this is a hyperlink that you can't click on when you're just looking at it on a slide, but there is a good hyperlink there. And there's an article there that has embedded with it an Excel spreadsheet, and it's really deeply buried in the article and really difficult to find. But one of the things you can do is you can put in how much data do I have, what tier is it going to go on, how much do I read and write the data, what's my average file size, block size, etc. And it will come up with, among other things, spending estimates, and this graph, which I think does a really neat way of showing how, what it's saying is the more you read a file, the more it makes sense to put it in a different tier. So in this one here, in the one on the far left, you're reading your files 1% of the time. So for every 100 gigabytes of files you put in storage, you're reading 1% of them back, which is great for like long-term archiving. So the archive tier here is dirt cheap, whereas the green tier, which is cool, is the most expensive. But as your rate of reading goes up, so if you get to the point where you're reading 100% of the files back, archiving, the archive tier is a terrible choice, and the green cool tier has barely budged at all in price. So actually, there's a way that you can sort of visually demonstrate where does it make sense to store my data. And then you get this sort of cutoff point, was it between about 25 and 50% there is when the race sort of starts and the purple one starts getting really expensive. But if it's just to sort of point out, in case you hadn't found it, if you ever need to do that sort of exercise, that's why you can do it. Oh, well, I assume there's some method we can actually post real links later on. Yes, okay. Another cool feature I want to mention briefly is index tags. So this is where, if you go back right at the start, there are some things that you can do with Azure Storage that you just can't with on-prem file system, and one is index tags. And if you imagine you've got a file share of some kind where everything's in directories, you've got files and folders and stuff, the only way you can keep any kind of logical order to them is by having some sort of semi-sensible naming convention around your folders. And sometimes that gets really messy. So you get these folders that's like a year and then a date and then a month and all sorts. It becomes difficult. But there's no way you can say, just go through this entire file structure and find me all of the files that are related to this thing or that have this tag or this were created by this user. It's really difficult to do because file systems don't like massive scans. Index tags are a key value pair that you can attach to any blob that can be used for some really cool stuff. So one is command filtering. So you can say, just show me the blobs that have got this tag. You can use them for automation. So say you wanted to, I don't know, process them in some method. You can use attribute-based access control. So that means you can actually apply role-based access permissions to a file or to a blob, depending on what tag it's got. So say you've got a mixture of like confidential and public blobs that are in the same file share, you can say, well, somebody has read access to confidential or read access to public, but not confidential, depending on what the tag is on the file. And I'll show you what this looks like in a sec. You've got blob inventory reporting, which is a way that you can actually get huge amounts of data around the blobs you've got stored. We've got the change feed, which is a kind of auditing function. And then we've got SFTP and HTTPS. I've mentioned those already. But the reason you might want to use HTTPS is because blob storage can form a really, really cheap way of storing static web content that you might otherwise need to put in a web application. So in this instance, we've got a web app, we've got some app service plans, we've got a SQL database. And if you imagine lots of websites, there's lots of like images and sort of background artifacts that are being loaded. If you can stick all of them in Azure Blob storage and then cache them on front door, it means so much less work for your web servers to do. So you can get away with having fewer and cheaper web servers because they're doing a lot less work. They're not sitting there sort of having to encrypt JPEG images and send them out. And I bet you when you've got websites, big websites that have got downtime, or for some reason like the BBC has fallen over and like is a global catastrophe, the last thing standing is going to be a sorry, the BBC website is down, static HTML page that served out one of these. Because this is probably like the web server of last resort for a lot of services. So another little demo. Now I'm going to get my phone out because it's got a list of, it's got this slide on it, so I don't have to open it again. So what am I going to show you? Not that much more after this, I don't think. So firstly, let's open Storage Explorer. So this is, let's say we've got a blob here. We've got our tags. We can open a tag. You can do this through the portal as well. I'm just doing it in Storage Explorer. At the moment, we have no blob tags on here. I can add a tag. I can press this button and create a sort of key value pair. What I've done is I've pre-populated all the tags I want on this storage in a table. So this is Azure Table Storage, and I generated all this as a CSV. And what I've got is my list of blobs that I want to attach tags to, and then I've got the tags that I want to attach. So I've got a classification, I've got a date, I've got an owner. You'll notice that that's all the Avengers there. And I've got a reference number. So say you've got like, I don't know, a case reference or something that you want to attach to things. And so what I've hopefully got is a little bit of magic. well, I wrote a PowerShell script, and it takes all the stuff that's in the table storage, and it applies those tags to the blobs, and it should whiz through all of them. But what it should also be able to do is check it later for inconsistency. So if for example, I've got some single source of truth system where I keep all of my data, was it a system of record for my data, and that gets updated. What I want to be able to do, hold on. Let's do that so I don't have to press Y 100 times. So what in that system of record, that might change. So it might say, for example, that the owner of this file has changed or the classification has changed. I can now periodically export that into a CSV, bring it into table storage as a kind of reference, and then periodically run through all my blobs and update them. So if the classification of one has changed from secret to something else, then I can update my blob and all of my access control changes. So this is a bit of PowerShell that I've got on my GitHub. I think it's the only thing on my GitHub because I'm not very good at writing code. But what this is doing in the background is going through all these files. It should. Yeah, there we go. So we've got our tags on here now.
Can you do this through policy?
I don't know if policy would do it. There may be a method coming soon that may be interesting that you may want to have a look out on announcements that may be coming soon. Possibly some sort of maybe. So probably not Azure policy. It was not that difficult to do in PowerShell, but yes, I think it is something that some people think. I don't know if you can use, so these aren't Azure resource tags. They are special.
Yeah, I doubt it's aliased, so I don't think you'll be able to even write a policy that would find it. The probably lowest level you could get is the blob and maybe the container, but you wouldn't be able to get much lower than that.
Anyway, so once we've got that, what can we do? So firstly, we can do some access control. So let's say we want to have the storage blob. We want to apply the storage blob reader to a person.
And this is a really good point, I think, back to your question, Alex, is this is data plane level stuff rather than control plane, right? So think about policy as more control plane side than data plane.
So we've got this little button here, add condition. And we can say build expression, add action. Want to read blobs. That's the thing that we want to give the permission to do. And we can say if the resource blob index tag classification string equals secret. I think there's a button where we can see this in JSON format as well. I can't remember where it is. But yeah, this is a way where we can basically say you have the blob reader permission if the blob has this tag applied to it, which becomes quite a powerful way of managing permissions as long as you can consistently manage the tags on your blobs. But that's one jazzy bit of functionality. But there's a few other things we can do. So we can extract what's called a blob inventory report. And a blob inventory report looks a bit like this. It's this massive CSV that's got all these different columns about the data. And it's got time and various sort of bits of metadata and MD5 hashes and stuff like that. And the one thing that's got the end is the tags. Now, I cheated a little bit. It sticks all the tags in as a JSON list in a single field, and I extracted them to separate columns just because otherwise I have to do a bunch of transformations in Power BI, and that made my head hurt. But the cost one, I've made this up, but it's very simple to add a cost column. You can do that in Power BI as well. But I brought it all into Power BI and say, of all my blob data, I can visualize it. So I can say, well, who's costing me the most amount of storage? How much of my data is classified or secret or whatever? It turns out that Black Widow is costing me an absolute fortune, and it's mostly secret stuff that she's holding on to, etc. So you can start doing some pretty clever data visualization quite easily. This is the sort of stuff that you would really, really struggle to do with an NTFS file system. I mean, yeah, you need expensive software to do this. I do not have expensive software. And then the other thing we've got is the change feed. So the change feed is the inventory report is a list of all the blobs you've got, which you can export. I think you set up a schedule to do it like once a day or something. The change feed is like an audit trail of what happens with the blob once it's in storage. So it chucks it out in this format called Avro. But this is a bit difficult to read, so let me just open the Avro format, and there we go. So we've got all these like blob tier change. So if you want to know every time a blob moves from sort of hot to cold because of a lifecycle policy, you've got an audit trail of all of that stuff. Quite why it's in this bizarre Apache Avro format instead of something else, I don't know, but clearly somebody thought it was a good idea. Anyway, that data's there.
Can you set a tag to propagate down?
It doesn't work the same way as tags in Azure Resource Manager, but well, you don't really have folders in blob storage.
True.
I'm sure that it would be very simple to script if you wanted to. Like that, all that stuff I did was just.
Does it work in the hierarchical namespace?
I don't know.
Couldn't answer. No. Try it.
I don't spend a lot of time thinking about hierarchical namespace because I don't really do like Synapse or anything like that. But possibly. But there's one really cool thing that's come out. There's announced at Ignite, and I've been doing quite a bit of work with the dev team on this one, so I think it's fun. And there are some customers who want to be able to prove the integrity of data. So they upload a bit of data into storage, and they want to be able to verify that that same data is the same. So 2 years later, 5 years later, for security and auditability reasons. And we've got this thing called confidential ledger, and that's been around for a while. So you've been able to use it for SQL transactions. And what confidential ledger is basically it's a blockchain that's computed inside an Azure confidential compute enclave. And so with a blockchain, what happens is it'll do a hash, and then the first hash forms the basis of the second one, and the third one, and the fourth one, and the fifth one. So at any point, not only do we have a securely stored hash of the file, but we can prove that the hash itself hasn't been modified. So I could say that it would be, you know, there's a hardware root of trust that proves cryptographically that the hash that I've stored in blob storage, in confidential ledger, has not been tampered with. As opposed to like if I wrote my hash down in on a post-it note, somebody could just say, well, you changed that. So if you've got like really critical audit trails that you need to manage, you absolutely cannot have any allegations of tampering of log files or audits or anything like that. This is a good way to do that. So I'll show you what this looks like. We have, where do we have some blob storage? So here I have some blob storage. Well, I've uploaded 3 files there. And what happens is I upload the files, and a function app, it sends a service bus notification that a file, a blob has been created. Function app triggers, runs a hash of that, that file. And that hash is computed within the confidential compute, and I can go and look at it over here. Again, table storage, because it's nice and easy. Storage browser. So there we go. Here is my timestamp transaction, blah, 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 and here's the hash. So this is a SHA-1 hash. And what it's doing is it's hashing the file contents, but it's also hashing it together with the E tag, which is sort of metadata, unique ID, and the insertion time. So if I try to overwrite a file, what I can do first is I can run an audit. So I'm going to go Python. And what this audit does, Just wait for that to return. There we go. So that'll take just a moment. What this audit does is sends this message to the same function app and says do an audit on this container. And if I wait just a moment, I can go into my there you go. So 2000 hours. That's now. So I've got an audit result. That takes a moment to load. It takes 2 moments to load. Oh, it's queuing the transfer. So clearly I chose the cheapest, poorest performing storage. Oh, come on, you can do better than this. There we go. Okay, so stored hash, computed hash, it's the same, right? So tampered false. So what I'm going to do is I'm going to tamper with a file. So where is my storage? So I'm going to upload one of these files again. And the file contents won't have changed, but the timestamp will have changed. And as a result, that'll mess up the hash. Overwrite. Yep. So if I then run my audit again, maybe a bit quicker this time. There you go. Tampered equals true. So it's recalculated the hash of the file, compared it to the hash that was stored in the confidential ledger, and said, no, we're not having that. So first one, false. And this one is marked as true because of some sort of internal magic of how the blockchain works, which we're not going to go into that one right now. But yes, it has marked that my confidential ledger has detected a deviation from the stored hash, and therefore, you know, my files have been tampered with. So that's quite a neat feature that I've been enjoying using, to the extent one can enjoy such things. And then I've only really got 1 or 2 other things to say, so I'm not going to go into storage, sync, and migration and stuff. But this one here, so I didn't want to sort of do war and peace on different types of availability and so on, because they're easy enough to look up, and you know what you can do and what can't do changes from time to time. But this bottom point, I do end up in an awful lot of conversations with people about how we require ZRS or we require GRS or something like that. And I can almost never trace it back to a genuine requirement. So what I would really love to hear is we require the ability to recover from a region failure or XYZ failure within a certain period of time, not we require ZRS. So ZRS might be the way you solve that problem, that's fine. But to just say ZRS, it's like saying our solution requires a load balancer. Well, why does it require a load balancer? Is it because you need to guarantee availability? Is it because you guarantee performance? Or is it just like you used to have a load balancer and you really like load balancers and you want another one? So I really try to encourage people to say, well, what are you actually trying to protect yourself from? So ZRS protects you from some things, snapshots protects you from other things, immutability and version protect you from things, but what is the thing you're trying to protect against? And not just assume that like ZRS is the minimum. We get sort of like, oh, well, we can't use archive storage because it doesn't support ZRS. But why do you need ZRS? What have you got at the moment for your tape library? So it's just kind of a little prompt to say, try to think about objectively about what your requirement is and don't confuse it with design decisions. I'm not going to cover sync and migration because I think you've probably all heard plenty about these services. But the last thing I wanted to mention is, firstly, of all the storage systems we've got, there are even more. So there's third-party storage. There's a web page on the Azure documentation that covers storage integration. So we've got things like Nasuni and Tiger. We've got these other ones, Panzura, Pure. I don't really know anything about them. I'm sure they're very good, but I've just never used them. But the two that I have come across is Nasuni is kind of, in a sense, similar to Azure NetApp files in that it's a sort of NAS type device where you put an appliance locally and then it synchronizes to cloud storage. And Tiger is a kind of Swiss Army knife of synchronizing files from one place to another. So if you've got something like an on-prem file share and you want your data to be tiered off into Azure Blob storage, it's really good for that sort of thing. So where Azure File Sync will just do a file server to Azure Files, Tiger Bridge will do sort of NetApp to Blob archive tier, or NetApp to S3, or whatever you want to do that, or you know, any combination of these different storage types. So Tiger Bridge is a really cool bit of software. And then the last thing I wanted to cover, and then I promise it's over, is this very new thing here. So this is something, now you saw that I'm a collector of badges at the beginning, and that for each one of those badges, I had to go and memorize a load of facts and then sit in exam and then forget all those facts promptly afterwards. And we've got this new type of certification that's called an applied skill. And at the moment, you can do this for free, and there's about 20 or so of them that you can do. But they're basically a lab. So you do your learning for the task that you're going to do, and then you go and do a lab. And at the end of the lab, it assesses you and says, yes, you have the skill of doing this. And one of them that we support is secure storage. So it's basically, I'll create some storage account and configure encryption, configure authentication, and so on. And it's a way where you can sort of, for relatively little effort, A, get yourself a credential that you can stick on LinkedIn, but B, just get some practice, because it's a way that you can actually learn how to use an Azure service and kind of do it the official, proper, secure, you know, well-architected kind of way. So yeah, go and have a look at applied skills if you haven't already seen them. And there's about 20 of them in all sorts of different things. And that's kind of it. I've run out of things to say about storage. I could go for several more hours, but I don't think I will. I'd get frowned at.
Well, firstly, I think let's have a huge round of applause for Daniel.
Thank you.
It's amazing how long I've been outside of dealing with storage and how much I actually gathered from what's changed and what's moved on since I was doing it on a daily basis. So yeah, mind blowing. So yeah, thank you very much. Have we got any questions from the audience?
Gosh. Oh.
Yeah, absolutely. Let's give you a microphone so everybody can hear.
Well, if we think about storage from, Cloud Adoption Framework or Logic Framework, some of the pillars of that, an example might be resilience. You touched on NRS, ZRS, GRS. How, and forgive me, I'm not as technical as I used to be. What are the limitations of the storage systems from a physical layer? We know lots about availability groups for compute, fault domains, update domains. Does that apply in the same way as for storage?
It does. It varies a bit from one storage type to another. So, for example, Azure NetApp Files has zonal and regional availability. Azure Files has zonal and regional availability, but they work in slightly different ways. So they work in different schedules. Broadly speaking, the way it typically works is that zonal availability is synchronous. So a write gets immediately synchronized with the entire zone, because the latency from one zone data center to another is typically less than a millisecond. And then writes to another region are asynchronous. So they happen, I don't know, on a 15 or 5-minute schedule or something like that. So that's typically the case. And I think that's the case for both Azure storage accounts and for Azure NetApp Files, and probably Elastic-SAN as well. So it sort of makes logical sense that the further away your data is going, the longer it will take to get there. But yes, they do have with them they do have with them availability guarantees. So just like with a virtual machine availability set or availability zones, you get a higher number of 9s if you enable that, up to the point of regionality when your higher 9s come at the expense of more complexity. It's the same with storage. So zonal storage, you don't really need to do any effort. You just need to pay a little bit more and you get the higher availability. regional storage, you then suddenly need to figure out, well, how do you fail over from your primary to your secondary storage and so on. So I'm not sure if that answers the question, but yes, it's more or less the same.
I guess when you're speaking to somebody about design decisions, you're thinking, what scenarios am I protecting it against? And even for LRS, you've got 3 copies of the data, right?
Yeah. So it's kind of like RAID or erasure coding, effectively.
Cool. Okay. Can I ask one other thing as well?
Yeah.
The other point is sort of cost optimization.
Mm-hmm.
And again, don't use Azure Advisor every day, but is there much intelligence existing or in the future around, I mean, storage is expensive, right?
Yeah.
It really does add up very, very quickly. And many customers will see a high percentage of their Azure bill is just storage, right? So is there much intelligence around, you know, you could be using a cheaper disk, or have you considered this? Or?
I think that's a gap. I think that's a big gap. There is one thing that you can think about quite easily, which is, am I using storage that is paid for by capacity consumed or by capacity provisioned? So with Azure Files Standard, you pay for capacity consumed. With Azure Files Premium, you pay for capacity provision. So if you provision 10 terabytes and then only use 1, then you're wasting money. But there is no tool, I think, that will tell you that. It's not like Azure Advisor will say, oh, this could be a smaller VM. I don't think there is a lot that will help you do that. Partly because it's kind of a bit difficult to gain insights into people's storage without the ability to see into people's storage, which we're not supposed to be able to do.
I'm just sort of thinking peak IO, you know, if you had a premium disk and it was just doing nothing, even though the disk is full, you know, it'd be nice to say,
I think
somebody's made a mistake, you could use an HDD.
Yeah, I'd like to think there are probably Azure Monitor community workbooks that will help you with that sort of thing. To say, well, you know, you've got something that's capable of 10,000 IOPS and you're maxing out at 200. But I don't think there's anything that's particularly good for that, certainly not in the portal. And B, changing storage after you've made decisions is quite a bit harder. So you can easily change a D4 VM to a D2. You just reboot it. But to change like a P30 disk to an S20 disk or something like that, you'd have to migrate the data to someone else. So there's effort and, you know, risk involved in doing that. So I'm not sure there is a way that you could just be given a button that says press here to save money without sort of potentially risking data corruption. Which
it's all the same disks underneath, though, isn't it?
Yeah, it's the same layer. I mean, ultimately there are different physical types of media, but they're all sort of abstracted as a unit. Does that?
Yeah.
Well, yeah, right. I haven't played much with Copilot. I've got it, but
I mean, like, especially when you're provisioning your services at the start, if you put in some like basic parameters, it does sort of advise you on particular SKUs and some of the compute nodes to set up. So.
And also, a lot of people don't know what IOPS they're going to need. I was like, the DBAs are probably the best at having that sort of idea because they can relatively easily measure another database that's quite similar. But storage performance is quite difficult to predict, especially when you're sort of trying to play it against all the other potential bottlenecks in the chain. So it's very easy to find the database that runs slowly and say my storage. I'd need more storage performance, buy a bigger disk, and then find that it was your virtual machine SKU that was wrong, or your mount options or something. So it's less easy to measure and less easy to change than virtual machines, I think, is the answer there. But it would be lovely if there was something that will tell you, like, here's how you could optimize it, even if it's just advisory.
I think some of it as well is, you know, using the features smarter and not making it harder for yourself. Like, I don't think you cover performance tiers for disks today.
No.
So, like, this is a feature that came out last year before, maybe.
Oh, well, the SSD V2s and stuff.
Yeah, that sort of stuff. But also, like, you could have a P6 disk, which is tiny, but you could give it a performance tier of a massive disk without changing the capacity size for it.
Yeah.
So you only pay a difference for its performance and IOPS throughput, rather than having to pay for the capacity provisioned.
Yeah,
so
it
is a clever way of using it.
It is easier with SSD V2s because you can scale the performance independently of the volume, which you couldn't do before. So with SSD V1, you buy a 20 terabyte disk and you get 20 terabytes worth of throughput. Whereas with V2, you buy a 20 terabyte disk and you can have tiny throughput, or you can pay more for large throughput and so on.
Yeah.
And you can also enable bursting on it, which you'd only really do if you were going to use it.
Absolutely. Any other questions? No. Well, thank you again for an amazing talk. I learned a ton, and yeah, hopefully.
I don't believe that.
No, honestly, like haven't touched storage in a long time. So yeah, it's been a good refresher. Thank you everybody for coming along and spending the evening with us. There's more drinks and a bit of pizza to finish off. For those of you who arrived late and need a quick snack before heading back, make sure you check out the drinks and food offerings. And we will see you all again in March. Thank you very much.
Just to add as well, if you're inspired to do a talk or you want to talk about anything, just please ping us, let us know, email, WhatsApp group, whatever.
Yes, absolutely. And we'll throw the WhatsApp slide back on the screen shortly for those of you who want to grab it. But if not, come and see me and Ryan. We can get you in there. Lovely. Thank you very much.
Cheers.